Newton's first law of motion. Newton's first law of motion states that an object will remains at rest or continues in a straight line at constant speed unless acted on by a resultant force. For example, as a car is at rest because the weight of the car is acting downward, and normal reaction forces from the wheels are acting upward. Total upward force is N1 plus N2. Total downward force is W. Total upward is equal to total downward force and resultant force is 0. A force of 200 newtons pushes a car forward. But friction acts on the car in the opposite direction with a force of 200 newtons. The resultant force on the car is 0, so the car remains at rest. A car is moving at a constant speed because the thrust force acting forward equals the air resistance acting backward, and the resultant force is 0. A ball is moving through the air at a constant speed because the weight of the ball acting downward equals the total of air resistance and upthrust acting upward, and the resultant force is 0. Therefore, we can conclude that no resultant force acts on the object, so it will either rest or move at constant speed and have no acceleration. Newton's second law of motion. Newton's second law of motion states that a resultant force acting on an object changes its velocity. This can be done by changing the object's direction of motion or its speed. When the velocity changes, the object is said to be accelerating, because the acceleration is the rate of change in velocity. The direction of the resultant force is same direction as the direction of acceleration. For example, if the resultant force acts on an object that is at rest, the object will start to accelerate. If the resultant force acts on an object that is moving in the same direction as the force, the object will accelerate even faster. If the resultant force acts on an object that is moving in opposite direction of the force, the object will decelerate even slower. If the resultant force acts on an object that is moving at a perpendicular angle to object's direction of motion, the object will change direction and the speed remains the same. Therefore, the acceleration, a, of an object is directly proportional to the resultant force, and the acceleration is inversely proportional to mass of the object. This can be expressed mathematically as F equals m multiplied by a, where F is the resultant force in Newton, n, m is the mass in kilogram, a is the acceleration in meters per second squared. For example 1. Find the resultant force and acceleration of the object, with magnitude and direction, as shown in the diagram. The resultant force is 15 minus 10 is equal to 5 newtons, to the left. The mass of the object is 500 grams, divide by 1000 equals 0.5 kilograms. From F equals m, a. Then a equals F divide by m equals 5 divide by 0.5, is equal to 10 meters per second squared to the left. Example 2. Find the resultant force of the object as shown in the diagram. From sigma F equals m, a, and knowing that the direction of sigma F is the right, because the direction of acceleration is the right, we can find the force. 10 plus F minus 15 is equal to 1.5 times 2. F equals 3 minus 10 plus 15. F equals 8 newtons to the right. Newton's third law of motion. Newton's third law of motion states that when body A exerts a force on the body B exerts an equal and opposite force on body A. A pair of forces must be equal in magnitude, opposite in direction, and act on different bodies. For example, a book lying on a table exerts a downward force on the table. This is the action force. The table also exerts an equal and opposite force on the book in the upward direction. This is the reaction force. The earth exerts a downward force on the book. This is the action force. The book also exerts an equal and opposite force on the earth in the upward direction. This is the reaction force. While moving on the ground, we push the ground backward with our feet. This is the action force. The ground also exerts a forward force on our feet of equal magnitude in the opposite direction, which makes us move forward. This is the reaction force. A man's hand exerts a force on the wall. This is the action force. The wall also exerts an equal and opposite force on a man's hand in the backward force. This is the reaction force. A rocket exerts a downward force on the burnt gases. This is the action force. The burnt gases also exerts an equal and opposite force on the rocket in an upward direction. This is the reaction force. I hope you found this video helpful. If you did, I would be grateful if you would subscribe to my channel, share this video with your friends, and leave a positive comment. Your support will help me to continue making videos and encourage me to create new content. Thank you.